So without any further ado, I'll go ahead and turn the presentation over to Glenn. Thanks a lot.
All right. So let's see what we have for today. Common solutions to parting challenges. Something along those lines is what we decided to call this topic. So just a quick rundown of what I'm intending for an agenda, a little introduction, a little discussion of single part processing, which would kind of be the predecessor to multi-part processing, which is the next thing that I would talk about is multi-part processing, which is really when parting tools start to become used a lot. And then a little discussion of who would be best to understand all these topics, and then some Q&A at the end. So introduction to this. What is a parting tool? Any tool that can be used to cut out the outside edges of your part, or whatever tool you are using to cut the outside edges of your part, is what I would call a parting tool. So if you're going to use a small round tool to nibble around the outside of your part, that's going to be your parting tool for this situation. If you're going to use a square tool, that would be your parting tool. Most commonly, rectangle shapes are what you normally would use for, or would think of as a parting tool. Usually a long, narrow rectangle shape. So maybe a 5mm by 80mm, or a 1/4 by 3. Probably those are kind of the most common parting tools. 1/4 by 4, most common sizes that we see as a tool manufacturer. So single part processing. So before multi-part processing became real popular, it was very common to do what I consider to be single part processing. So you would pre-shear your blank to the correct size for one part, and then put that one part on your punch press to punch out the interior holes, and maybe punch corner notches or trim the ends of the part. So that's kind of what had been historically a very common way to process parts. And still a number of people do things that way still today. And some of the problems that we see with that, right off the bat, you have to pre-cut your part to the correct size. That's an extra operation to cut that blank to the correct size. It's not the easiest process in the world to cut that to the correct size. Typically that's done on a shearing machine, and those blanks typically are not real consistent. They're maybe not as square as you'd like them to be. And then just the fact that you're running one part at a time is not terribly efficient. It's extra handling of the part. It can be difficult to run one part at a time because you have the clamps that are holding the part. Those clamps might be in the way of holes that you need to punch on the part. And then those clamps, being that they're clamped right on the part, that causes trouble sometimes because the clamps can cause marks on the part or distortions on the edge of the part. So those are some drawbacks to that single part processing. Multi-part processing is kind of what I see as the next step in the evolution of the punching process, where you're using a common blank size and running multiple parts in one program. So on my previous slide, I've got that one single part running horizontally with the clamps on the edge of the part. And then in this slide, this is the same part, but I've got a sheet that's large enough to handle 8 of these parts. So the benefits to that, the way I see it, first thing is the fact that you don't need to pre-cut the blank. The actual blank size then is not very important anymore. As long as your blank is big enough, you're in good shape. So if your blank isn't square or if it's a little bit too large, that's just fine. Another benefit is the fact that you're running multiple parts at one time. So for these internal holes, as long as you're using, let's say, a round tool to punch the internal holes, you might as well punch all 8 parts at the same time instead of stopping and doing one part at a time. So that means you've got fewer tool changes. You're waiting much less time for the turret to rotate or the punching machine to change tools. So you gain a lot of efficiency there. And then you're also, I didn't write this one down, I don't think, but you're cutting all the way around the part, so the accuracy of the part generally is much more accurate than the single part processing where you're relying on the shear to cut the part to size. Another benefit is you can do much more complicated parts. So you can see this kind of triangle sort of shaped part that I've got here. You wouldn't really be able to shear that out. So you're going to need some sort of a parting tool to cut around the outside edges of this part. So you can use your punching machine then to make much more complicated parts. Another benefit is the fact that you can nest your parts together. So on the left here, I show an example of 12 parts on a sheet, kind of an L-shaped part. And then on the right, the same size sheet of metal that can fit 24 parts on there. Yet another benefit is the fact that you can run groups of parts. So instead of just running one part in a program, you can run as many parts as you want. So if you have a kit to make an assembly, you can run those all at one time. Or sometimes we'll see people do the kind of combine the nesting concept with the grouping of parts. And they'll use multiple parts on the blank just to increase material utilization. So you might possibly put some extra parts on the top left and top right corners if you got another little part that you could drop in there. So we started out with the weather pull. Let's do pull number 2. How are you currently processing your part? Primarily single part processing, or are you doing primarily multi-part processing? Or maybe a combination of both? Let's kind of see where people stand. All right, so we'll just wait a few seconds here while this thing gets tabulated, and we'll see the results here. So there it is. Looks like nobody is primarily doing single parts anymore. To me, that's a good thing to see, because it's not really a very good way to process your parts. Most people, it looks like, are doing multi-part processing. Some people are saying they do an even balance of both. Kind of depends, of course, on the mix of parts that you do. Sometimes single part processing still does make sense for you, depending on how you're doing things. So a little more on multi-part processing. We talked about some of the benefits. What are some potential problems? Right off the bat, one of them is wasted material. Because you're going to punch all the way around the outside edges of the part, that means you've got some wasted material around the edges of the sheet. A big one is the trim strip, where the clamps are. There's some dead zones around the clamps, so typically the biggest wasted material is where that trim strip is, where the clamps are. But you also need some borders around the edge of the sheet as well, and some borders in between the parts as well. Another problem is nibble edges on the parts. So when you're taking your 1/4x3 rectangle, for example, and trimming a long straight edge, you are going to see some overlap marks where those 3-inch punch hits overlap. Poor edge quality, that would mostly be an issue of poor tool maintenance or alignment or something like that. And we will talk some more about these potential problems and potential solutions as we go here. Complicated programming, can be a big problem. Compared to single part programming, when you start doing multi-part programming or processing, you have a lot more complicated programs. I guess I found that to be a complicated sentence to come out with as well. So, punching your forms, sometimes that gets to be an obstacle for you. You've got embosses, extrusions, louvers, whatever you have. Now you've got to try and punch close to those forms. That can be a problem. Higher tooling costs, because you're doing more punching, all this extra punching around the edges of the parts, that increases tooling costs. And then just longer punch press run times just because of the extra punching. So that's kind of a trade-off. We talked about increasing efficiency because you're doing multiple parts at one time, but you are also doing more work on your punch press. So some solutions. You got wasted material was the first potential problem that I talked about. So one thing that's very common is to use a tool with a relieved stripper. So I've got a picture here on the right side. I've got more of a traditional tool. Let's see if I can pull up my annotations here and draw a little bit. See if this works. So here on the right, I just kind of circled crudely in green. The flat tool, that's kind of the traditional tool. That's got a big stripper plate that comes down, and that's kind of where your big dead zone around your clamps comes from, is because of that large size of that tool. So the tool on the left, you can see that you've got the relief that is designed to be able to get close to clamps. Usually what that allows is you can get within about 1 inch of the clamps. The ability to utilize a tool like this is somewhat dependent on your machine. Some machines really allow this type of tool to get right in close to the clamps. Other machines make it a little more difficult because they're wanting to be cautious that you're not going to punch or damage the clamps on the machine. So if you're thinking about switching from the tool style on the right to the tool style on the left, you might want to check and make sure that your machine is going to allow you to get close to those clamps. Nibble marks on your part edges. This is a common thing that we hear about, and there's a number of things that we've talked about and we see customers doing. First of all, it's worth your time to check your station alignment and your die clearance and make sure that you are doing the best job you can of punching the hole to start with. We see a number of situations where a lot of improvements can be made just by making sure you're using the correct die clearance and properly aligning your station, making sure that those situations are in good shape. And when we talk about the correct die clearance, it sometimes is not just a matter of looking at the chart and seeing what the recommended die clearance is for a certain material thickness. It may be worth your time to look into and experiment a little with what is exactly the right die clearance for this particular material that we're working with. We do find sometimes that small adjustments in the die clearance can make some substantial differences in the quality of the cut. The next thing I listed here is try running an A-Brown punch in your rectangle die. It sounds really strange, but we do find a lot of customers that try it and really do like the results. It's a simple matter of switching to an A-Brown punch, leaving your rectangle die exactly as it was, but switching to an A-Brown punch. And then another option is using something like a rolling pincher tool, one of the Wilson wheel tools, or even just a simple dash tool, but the rolling pincher tool really is one of the best ways to do it. So you would put a groove in the top and bottom of the sheet, and then punch along that. So you're going to put that groove right on the edge of the part, and then when you punch, a lot of times you will see much better looking edges. That's something that we could talk a lot more about. So if you want more information about these ideas that I'm talking about here, go ahead and give us a call or contact your sales engineer or whatever, and we can work on getting you more information on that. Pour edge quality. Similar to what we were talking about before with the nibble marks on your part edges, but again, check the condition of your punch and die. Do they need to be sharpened? Are you using the right die clearance? Is your station alignment correct? And this can be a big issue with the auto index station. Make sure that you have your auto index station dialed in correctly relative to your X and Y axis. And that can even sometimes be a case with non-auto index stations. But if you find yourself punching a straight line parallel to the X-axis and if you're getting rat tails on your slugs or kind of a stair-step edge on the cut that you're making, that's something that is definitely something that should be looked at as far as, is there something wrong with the tool or something wrong with the machine or what's going on? You should be able to avoid those problems. Again, that's something that we could look more in depth into if you feel like that's something you might want to try and address. Complicated programming. That can be a big issue with multi-part processing. Poor programming can definitely cause a lot of part inaccuracies, and you really should these days be looking at some sort of an advanced programming system. There's lots of different programming systems out there, provided in some cases by the machine manufacturers, but probably more often the good systems are really developed by independent software suppliers. There's a lot of good systems out there. And having an experienced programmer who is really paying attention to how these programs really work on the shop floor helps a lot. So encourage your programmers to really think about, are these programs working right? And then get down on the shop floor and watch how those programs are running. Are things working correctly, or are there things that can be improved? Punching near forms. Relieved tools definitely can help. So that type of tool that we talked about, being able to punch close to clamps, that can also punch very close to forms. And there's a number of other ways that we can relieve tools as well. And also urethane strippers. We see that used in a number of cases. Depending on the tool style, urethane stripper can definitely help better. Again, this is another thing that we could talk more about if you've got questions a little bit beyond the scope of what we're trying to talk about today. Higher tooling costs. Because of all this extra punching, you're using these slitting tools, parting tools for a lot of hits, so it's a tool that you really want to have the best type design tool that you can. So better tool designs and improved tool steels can really help that. And we will talk more about that coming up here. Longer punch press run times. I guess probably the main thing that has leads that is just the fact that current machines are much, much faster. So back 20, 30 years ago, when single part processing was much more common, part of the problem was the machines just really weren't punching very fast, weren't moving the sheet very fast. So to add all this extra punching really added a lot of extra runtime. That has gradually changed, and machines do run a lot faster now than they used to. I think you guys are mostly aware of that. Now, I said I was going to talk a little bit more about the tool designs and tool life, so let's talk a little bit about that. Because these long, narrow shapes are so common for this parting that we're talking about, Wilson Tool went ahead and developed what we call a DuraBlade tool. We did this about 10 years ago, roughly. It's a tool designed really from the ground up as a long, narrow rectangle shape. It really doesn't address anything besides that. So we designed it just for long, narrow parting tools. The body of the tool is designed to rigidly hold this long, narrow blade. So instead of starting with a round shape punch and grinding a rectangle shape onto it, we designed a tool that is really designed around this long rectangle shape. The stripper plate guides the tip of the punch, so instead of just letting that punch tip have clearance and able to float around, the stripper plate does guide that punch tip right down to the sheet. The stripper plate is relieved to allow punching closer to clamps and forms. And the punch blade that we're talking about is made of a premium powdered metal, so it has much longer tool life. So I've got a little video here of kind of what this tool looks like. So let's go ahead and let that run. See if I can get that pulled up here. And let's see what that looks like. So that video shows, there we go, shows basically this tool that I've got on the slide now. So you can see in this picture, you've got a tool with the body of the tool. Again, I'll try to highlight it in green. You can see the body of the tool has a big slot in it that's made to hold this rectangular shaped punch. And then the body of the punch has this very solid base that slides into the slot in the body of the tool. Holds that punch tip very rigidly. It's real easy to mount and unmount that punch in there. And then the stripper plate, you can see, is relieved on the sides to get close to clamps. And you can't really see, but the slot within the stripper plate is built so that it's just a very tight clearance around the punch tip, so that it really helps guide that punch tip and hold its alignment very, very accurately. This is the design for thick turret machines. We also have a kind of a matching die concept that goes along with that Durablade punch concept. It's a die body with an inserted powdered metal insert that's much longer lasting than standard dies. Back looking at the punch again, we make a design similar to what we make for the thick turrets. This design is made for thin turret machines, strip-it style thin turret machines. And then we also have a design for trump-style tools. And typically a trump-style tool would have a separate stripper plate, which definitely can cause problems with being able to get close to the clamps and close to forms. This Durablade style tool, in addition to having the very strong, beefy body designed for specifically for long, short, narrow rectangles, it also has an integrated stripper plate, which is got springs behind it to do the stripping. So we find that this has been a very good solution for a lot of customers. So these are some of the basic concepts of parting tools that we've found to be very important over the years. So who do we feel like really needs to understand these concepts? Well, one of the first things is manufacturing engineers, whoever is making the decisions about, are we doing multi-part processing, what tools are we going to use to do these processes. This really kind of needs to be analyzed by manufacturing engineers to do cost justifications and look at, does this make sense to do it this way, or should we be doing something other way? The estimators, of course, if you're going to switch from multi-part processing or from single-part processing to multi-part processing, that's a big change as far as how estimating is going to happen. So cost and pricing definitely is a big switch. They need to understand that. But programming is also a huge deal. Programmers need to understand the consequences of what they're doing and how that multi-part processing and or nesting is working. And then the tool setup and machine operators, we talked about a number of these situations, what the solution was to look at station alignment, die clearance, a lot of those kinds of things. So this really is up to the tool setup and machine operators, being sure that they understand the needs for keeping the tool clean and lubricated, how it's properly reground, station alignment, and so forth. And then, of course, purchasing. Who's going to buy these tools? Purchasing a lot of times has different needs or different goals as far as how they're deciding what tools to buy. Sometimes it just simply comes down to price. But with something as important as the parting tools, price is usually kind of low on the list of what's really important as far as which tool to go with. So kind of in summary, what we talked about is what's the definition of parting? We find that to be kind of useful to make sure we're talking about the same thing all the time. Talked about single part processing, and it sounds like most of you have already gotten over that hurdle. Multi-part processing, we talked about benefits and problems, and then we also talked about who needs to understand these issues. So I think we are probably ready to do the last poll, I guess, which is this question of, we talked about a number of things that we have more information available on if you were interested. So the poll here is kind of asking, if any, which of those topics would you be interested in getting more information on? And I think we're just going to let that poll sit open and let you go ahead and check as many of those items as you would like. And then we'll kind of move straight into the Q&A section.